I'm Bob Plankers. Some of you know me, and I'm sorry about that. And others we've not met, but it's a pleasure to be here. I've been on that side of the table as well. So those of you that know me know that I talk a lot, and I've been talking a lot lately in the last few years about security and compliance, especially with VMware products, and especially in infrastructure. I'm an old school IT operations person, and so so let's get into it here. Just talk about, I'll start at kind of a high level and work our way in. 30 minutes is not a ton of time, but we could talk about this stuff for hours, and you may not want to. That's probably a blessing. So anyhow, our approach to security, we really try to take an approach that, out of the box, not that there is a box anymore, but out of the box, it's secure. You don't have to do a whole lot to secure it. The defaults are set correctly or in some sort of sane thing. Maybe compliance has got your regulatory compliance has got other ideas in that, but you can just turn it on and keep moving, and be able to change things later, perhaps. And that comes with my second point, that things are easy to use. If things are simple, people will adopt them. If things are simple, try to get rid of a lot of that friction. VMware, now Broadcom, the VCF division of Broadcom, has a small army of user experience designers, and we bring them to bear on problems like this. How do humans interact with this stuff? How do humans turn these security features on? What friction might they have? Can we get rid of that sort of stuff? And that eases regulatory compliance. We often get people in organizations asking, in a panic, how do I do X? And it's super easy. They never believe me, but a lot of it actually is really easy. And then can we make it consistent and consistently available across the whole stack? We're doing a lot of good work on that right now in the VCF stack, and I'm proud of it. And along the lines of the UX side of things, and engineering too, can we get rid of trade-offs? We often say that security is always a trade-off. There's always performance or budget or staff time trade-offs. Can we minimize those? A lot of times we can, and get rid of some hard choices, especially, and new hardware too. We can work with our hardware partners and guest operating system partners and that to try to make security just a baseline. It's just an intrinsic property of the system, and it should just be there. The way I see security is always through the lenses of the core tenets of information security, the CIA triad. Confidentiality, the idea that we're keeping our data out of the hands of, unauthorized people, unauthorized groups, that sort of thing. And this is what everyone thinks of as security, but it's only a third of the puzzle, honestly. The integrity, when I leave data somewhere, I want to come back and find it in the state I expect it to be in. And, and it's trouble if it's not, and that's not even just attackers or, a breach, somebody changing it. Could also be a disk array failing, a drive array, a storage array is not authorized to change my data. So why did it? That sort of thing. And then availability. What's the point of these systems? Why did we even build them if they're not available to us when we need them? And so availability is really an interesting point. And it's actually sort of the bread and butter of classic vSphere. You think about vMotion and all of that stuff. And there's a lot of availability and resilience. It all comes down to resilience. How can we be resilient in the face of an attack, in the face of problems? And I like to comment that this also makes, and I come at this from a sort of a manipulative point of view, you can justify all of these things, turning on security features, doing all of this stuff, because everything then in vSphere and VCF is a security feature. And I'm sure some of you will think of something that isn't directly mappable into this, but we can map pretty much anything into one or more of these categories. And that's a really powerful thing. Like I said, even just to justify to an organization why you want to do it. Who's going to argue against turning on a security feature, right? Well, lots of organizations, as it turns out. But what do we do about it? So how do we implement this in infrastructure? And I do want to talk for a second about the difference between infrastructure and workloads, because infrastructure, we talk about zero trust. Zero trust gets bandied about quite a bit, and a lot of the zero trust stuff out there, you look at it and it's like, whoa, you added a million different components. It's like all the trust, and so zero trust, we're getting rid of trust, not adding to it. But that's a lot easier for workloads too. The workloads have got a different set of tools available to them than infrastructure does, because infrastructure, there's still a lot of trust. Trust in hardware, which may or may not be misplaced. Trust, and we'll talk about that in a little bit. Trust in storage arrays, network equipment, all this stuff we're attached to. How do we validate it? And there's work going on those fronts, but it's not here yet. And so what do? Well, we have to layer in other things, and that's how we do it. Defense in depth. So we've got these different layers, and I just kind of want to go through for a little bit here and talk about the different layers. So one, at the hardware level, we've got a bunch of stuff. Ignoring CPU promises about, isolation and whatnot. Those are interesting things too, CPU vulnerabilities and that. But secure boot's been around for 14 years now. It might even be 15 at this point. People should use it. It's actually not that widely adopted, oddly enough. Hardware trusted platform modules, the ability to store secrets in a secure enclave that's hard to get into inside the server, that's a useful tool. And then, turning on AMD SEVES and Intel's trusted execution technology, if those things are on, then ESXi, that's the next level. We install ESXi, and the ESXi can use those tools, to validate its own existence, its own boot process, use TXT to validate processes and things. But we also get some advantages at the ESXi level. We've got some features built in and some capabilities there. Code signing, the ability to deny execution to a binary that hasn't been signed properly, but maybe it's been signed properly, but just the wrong people. That's all, and that takes a lot of the rootkit tools off the table. The malware toolkits that you hear about that have all the crazy names, Hello Kitty, all of that stuff. The inability to use those by default is really nice. Configuration encryption. We encrypt the ESXi configuration now and store it in an encrypted form on the boot device. That's helpful for confidentiality. If you've got a TPM, we'll store the decryption key in the TPM. If you don't have a TPM, we'll store it in a file right next to the encrypted one, but it's no worse than it's ever been. It's just not any better. This is why we encourage trusted platform modules. Key persistence sealing, we can store a lot of other things in the TPM as well. We can persist encryption keys if you've got a use case for that. There's not a lot of use cases for it, but some, and again, being flexible about this sort of thing, because everyone's different. And that's another real challenge to security is, no security, no compliance effort survives contact with one's workloads, really. CPU schedulers. We've got three different CPU schedulers, depending on how much you trust your CPUs. If you've got CPU vulnerabilities, most of them, you can control the hyper-threading, the symmetric multi-threading that's available there and available to workloads, and that helps immensely with mitigating CPU vulnerabilities. And then we've got a sandbox in vSphere 7, and we keep improving it, and we're going to continue that off into the 9.0 and the 9 time frame here around the virtual machine monitor. The process, if you were to log into ESXi and type PS, you can see all these different processes, and those are all your VMs. And a lot of them are your VMs. There's other things too, but the around that virtual machine monitor, the process there is a sandbox, and that sandbox, its only goal is to keep everything in the sandbox. It knows exactly what the monitor should be doing. And if it tries doing something weird, like an attacker trying to do a VM escape from the guest operating system out into ESXi, which is bad news. And it happens from time to time. How do we control that? And the sandbox does a really good job of controlling that. It's not perfect, but when we talk to security researchers, we talk to a lot of security researchers, and they generally tell us they hate the sandbox, and that makes us smile. So moving on, we install vCenter. Now we've got the classic vSphere, and vCenter can come along and do some host attestation. It can take the data from the TPMs and secure boot, and it can say, hey, this host is in a wacky configuration. Dear human, can you come and sort this out? And we can tie that to other penalties, access to encryption keys and that, using vSphere Trust Authority as well. Native key provider. It makes it really easy to turn on. So you need a key provider to turn on VM encryption, vSAN encryption, and vSphere, VCF can do it all itself. I mean, you can still connect to a KMS, no problem. That functionality is not going away anytime soon, but it's not going away at all. It's not even on. That's an important part of the functionality because there's different use cases there. But native key provider, you can be encrypted from the start. And that's really important, especially for NVMe drives, that they're really hard, or if not impossible, because of their wear leveling and the technology there, they're really impossible to sanitize. And so never writing unencrypted data to them is super helpful. And you can do that. You can do it from the start. Identity federation, we'll talk a little bit more about this in a minute or two or three, but the idea that we want to federate, other people are better at identity than we are. And so let's let them do it. It's kind of the old Unix school of thought with, one tool does a good job. Let's let it do its thing. And so federation is in our future. Getting out of the business of identity, adding two-factor authentication everywhere where we still have stuff, but then, turn over most of it to a federated broker, that sort of thing. And then last at this level, we get vMotion, we get DRS, the distributed resource scheduler, we get high availability, we get fault tolerance. And these are absolutely security features. And just like I was talking about earlier with availability, the ability to move a VM around without it even noticing most of the time, and so that you can patch the underlying infrastructure, that's huge, decoupling. Having things automatically fix themselves, that's really nice, or at least recover in a rapid fashion. And then some human, you don't have to wake them up at night, everything comes back up and you can sort it out in the morning, that sort of thing. I always appreciated that. Workloads. Turns out our customers usually want to run workloads. They don't just run vSphere and VCF just for the heck of it, like we do sometimes. But all these workloads starting to need VTPMs, the virtual TPM 2.0 that we can add to a VM. Support virtualization-based security. That's Microsoft's way of describing. It's nested virtualization is what it is. They use a little layer of Hyper-V in there to create a secure enclave for secrets inside of Windows, and we support that. We support it natively. We've supported it since vSphere 6.7, and it's very performant. It works great. And that's really important now to Windows 10 and 11 and the Windows Server 2022 and 2025. And anybody doing any regulatory compliance is going to check for that. We can present Intel's SGX to a guest operating system if you want it. Same for AMD SCVES as well. And so that's really nice. We can pass that stuff through, and more technologies coming along the line there. We go up yet another level. We've got this Cloud Foundation thing, and so we start seeing the bigger picture. And I know we've talked a lot today about Cloud Foundation, but the idea that we can do more lifecycle things, the whole stack, do more configuration drift management, not just inside of hosts and whatnot, but, across everything. And then centralized certificate management, password rotations. These are just the annoying things that customers tell us that they wish they could just be done with. And we're like, okay, we can work that out. And so we put that in STDC Manager. We put these in the tools. If we can get people back to focusing on security faster, actual productive things faster, not that these things are bad, password rotations, super important. But, can we minimize it? Yeah, we can. There's other things that come with Cloud Foundation then too, of course. ARIA operations, continuous monitoring, especially for security controls. That's really nice. Not even for breaches, but we hear from customers that it's just nice to know ahead of time before they're audited, or that if they were troubleshooting something, they went in, they undid some control and they forgot to put it back. I used to get some razzing from my team about that back in the day, that I would do stuff and and I wouldn't put it back. Hey, Bob, what are you doing here? ARIA automation, super important for governance, the governance aspects of things. The NIST Cybersecurity Framework 2.0, been released earlier this year, it used to have 5 things on it. Now it's got a 6th, a big old governance thing in the middle of it. And ARIA automation helps immensely with that. And then I think it was Captain Picard. Well, I'll talk about NSX first. Gluing all the vDefend, the distributed firewalls. A lot of the workload capabilities are found in NSX. But then live recovery too. I was going to say Captain Picard in Star Trek: The Next Generation said once that you can do everything right and still lose. And that's absolutely true in security. And having an insurance policy, having a backups you can rely on, backups that can get you back on your feet fast, that's super helpful too. And so a lot of cool stuff here. Let's talk a little bit about what we've been doing at the core of the product, to help, I can't escape a Cloud Field Day without talking about patching. Yeah, what's up?
I wanted to interrupt and just, you don't have to go back in the slides, but a question on identity federation and certificate management. It seems like you're doing the exact opposite. You're getting out of the human identity business, but getting into the machine identity business. Can you sort of
Yeah,
a little bit more about that?
Yeah, sure. We want to, so authenticating components to each other, how does that work? There's a lot of stuff there, and how do we establish trust between components of the infrastructure? A lot of it's certificate driven right now. A lot of it's we use a lot of clues that something is trustworthy, but can we do something better in that regard? Can we actually establish trust, and can we tie it to like host attestation state, like where you can actually validate the state of things? And so, yeah, not much going on right now in the product, in the shipping product, but these are all things that we're looking forward to doing, and then to your point, Jack, offloading the human identity to something that's better at it, is a real goal of ours, and then be able to unify that across the entire stack. So does that make sense?
It does. Are you still going to be able to federate or participate in other certificate management schemes?
Yes. Yeah. The idea is multi-tenant federation, so we're, be able to participate in different ones. That'll come across the entire stack and the entire 9.0 timeframe, for example. We're doing a lot of work on this front. So
excellent. Thank you.
Hey, Bob. You didn't mention specific encryption algorithms, but where are you guys with respect to post-quantum encryption support?
Post-quantum, yes. So the algorithms that we've got right now, and I'm actually going to talk a little bit about the cipher suites. Oh, wow, we can talk about it right now. In fact, so trying to move towards cipher suites that are post-quantum safe. The trying to do that. We've got as a vendor, we've got a really interesting line to walk between the inertia of our ecosystem, which say they want change, but then sometimes we complain about the change when we make a change, and then being able to do this sort of stuff. And so major versions are where we do most of that, but with vSphere 8 Update 3, we did introduce something, TLS profiles, where we can actually cut down, instead of a compatible set of ciphers that are available, we can cut it down to just, post-quantum safe ones that don't annoy compliance scanners, frankly, that sort of thing. And so that's on our mind. It's deep on our mind. TLS 1.3 is a big thing as well. Moving forward for us, again, 8 has TLS 1.3 in it, but mostly just internally. Moving forward, that'll be exposed as client-facing stuff more directly. Again, compatibility, ecosystem. We've got to walk that line. So. But that's the way we're going to. The quantum thing is going to hit us one day, and it's going to be a 0 day. Frankly, it's wham in our face. So, make sense?
Yeah.
Excellent. Good questions. Well, here, let's just get into it a little bit. A bunch of different stuff going on with lifecycle management. Doing a lot of desired state declarative sorts of things. Moving forward here, we've switched from Lifecycle Manager to from the old Update Manager sort of methodologies. Update Manager was fine, but it would just patch whatever was there. The more the merrier, that sort of thing. Lifecycle Manager does get upset, with the image-based lifecycle stuff if there's something extra there, malware, for example, that happen from time to time. And so this desired state, basically defining a state that we want something to be in and then enforcing it, really interesting to us moving forward. And that also means we can continuously monitor for deviations from that state. So configuration profiles is to host profiles, what lifecycle manager is to update manager, that sort of thing, and pushing this forward, improving this as we go, being able to take JSON imports and things like that, some more modern stuff. Even some of the underlying features, vMotion, we rewrote in vSphere 7, rewrote it almost completely. And DRS, we keep making DRS smarter and smarter, especially as hardware manufacturers, CPU manufacturers, they start exposing more stats to us. We can use those to make better decisions, especially around memory tiering, memory bandwidth, all of that sort of stuff. And, and that helps take the friction away from patching. And that's, we want to do that. We want people to be able to update their stuff. We want people to be able to service their infrastructure without fear of application admin retribution. I don't know a better way to put that sort of thing. We don't want that sort of friction. So another big way we're working towards reducing the friction is Live Patch. We announced this as part of ESXi Update 3. Driven by vCenter and now VCF 5.2 and 5.2.1 can take advantage of it. The idea that we can be less disruptive and allow for faster updates. And it starts with a virtual machine monitor. This is our starting point. We're expanding that as we go forward here to other components of ESXi, but we had to start somewhere. Virtual machine monitor, in that VM escape situation I was talking about, we want to be able to rapidly update the hypervisor, rapidly update ESXi to cover this situation, without having to patch thousands and thousands of workloads, that sort of thing. And so being able to do that is super cool. Partial maintenance mode, we had to invent a new maintenance mode. So we've got maintenance mode and no maintenance mode, and then partial, where workloads keep running, but you can't make any changes, that sort of thing. And then it's all on premises. There's other live patches out there that are cloud driven, and that ours are all local, driven out of vCenter server. And so let's talk a little bit about how it works. First, there's this virtual machine monitor. We put the host in partial maintenance mode. We basically make a copy of the virtual machine monitor, and then we patch it. Pretty straightforward there. And then what it amounts to is just a process level vMotion is what it amounts to. We're talking microseconds here, not a full vMotion or anything like that, but reroutes all those system calls to the new copy of the monitor, and away it goes. The workloads don't notice at all. There's, network glitches that happen in lots more, take a lot more time than that sort of thing. So, but a few microseconds, and it's orchestrated by the CPU scheduler. So not a huge problem there. Like I said, we do start with a virtual machine monitor. So there's only some things that we will be able to patch this way. You'll still need to reboot for other things. Again, we're working on that. That's part of our roadmap. What else can we do? Some host configurations aren't compatible yet. I'm working on that. And and so you'll know that there's a compatible build. It'll just say it's compatible with the live patch. It's got that tag on it. So, so what else are we doing? Well, all this image-based updating and lifecycle stuff is great, but people want to be more flexible about it. And so we've extended it. We've listened to a lot of feedback around this, and our product managers and engineering teams have been really working on customer feedback, working off of the customer feedback. And the ability to remove components now too. A lot of servers are delivered from a hardware manufacturer with a bunch of stuff installed, and people don't necessarily need all of that. Want to reduce their surface area there, attack surface, that sort of thing. And so being able to remove that, you can even get rid of the host client now, and it still leaves the APIs. You can still do some stuff, but you can get rid of that as well, and not have to worry about it if it is something you worry about. vCenter. We've done a lot to de-risk vCenter updates as well. We can do what we call reduced downtime update. It's basically doing the same thing for vCenter as a major version upgrade, except for a patch, where we deploy a new VM, we copy all the data across to the new VM, And then we cut over to it at a certain point, and our goal for that cutover period is less than a minute or less. And again, with anything in IT, if IT had a motto, it would be, it depends, right? And so, it depends on hardware and things like that, but it's not far off. And, yeah. And so you can still start up the old one if there's a problem, but, a lot of organizations can actually deal with a minute. That's a lot less cumbersome than the converting data as part of post-install sort of vSphere patch that you sit there for 30 minutes, that sort of thing. So if you don't want to do that, and there's a lot of folks that don't, it turns out we can use, we've started using the logical volume manager that's in the Linux. So VCSA is a Linux appliance, no secret there, and it uses logical volume management. Well, that's got a snapshot functionality in it. So we just snap the application volume, and if something goes wrong, you're prompted after the patch. What do you want to do? Do you want to keep trying? Do you want to roll it back? That sort of thing. And so again, just trying to de-risk a lot of this stuff, make organizations less wary of patching so that they actually do it and, remove the vulnerabilities, stay up to date, that sort of thing. We talked about ciphers. I already talked about the compliance-friendly ciphers on TLS 1.3. Just being able to replace certificates fast as well. Just little things go a long way in these spaces. And then same for identity federation. We've got ADFS. We've had ADFS since 7. Everyone loves to hate ADFS, but it's a decent on-premises sort of virtualization of identity federation tool, and we can plug into that. We've got direct Okta support, direct Entra ID support, ping federate now in 8.8.3, and then we'll add more generic SAML and OAuth 2, OIDC support moving forward, that sort of thing, so that we can plug in whatever people have, that sort of thing. And then more nerdy things deep in the product too, as we learn about attackers that are using things. Any tool that's useful for a sysadmin is also useful for an attacker. So we need to balance that a little bit, but there's some stuff that we can take away. ptrace, the debugging hooks, we can take those out of there. Turn exec install only on by default so that there's code signing. ESXi 8 has got the ability to more granularly control shell access for local users. That's super helpful. You can also deny them a bunch of capabilities there and monitor for people attempting to use those capabilities. And that's a huge thing too. MEMeager 0, the ability to clear out a VM's memory space after it's been powered off. That's super helpful in terms of memory controller attacks, things like that. And, because that's actually how a lot of folks are being breached now. Recovery of tokens, keys, authentication components, that sort of thing, secrets that way. And Logging is boring, but it's really important, making it all RFC compliant so that we can feed it to log engines like, ARIA operations for logs, that sort of thing. Getting ESXi to be a little less chatty. It's very chatty sometimes, and I'm very chatty sometimes too, but we all need to be quiet sometimes. And then VMK access, our fancy name for the sandbox, improving that moving forward. So that, the couple of times that people can get through the sandbox, we can close that off and have different approaches. Move that stuff into user space, for example. Deprivilege the VM monitor is a really interesting thought. We track all of the stuff in our security configuration guide. It's been around for about 15 years now, about as long as Secure Boot. And we've extended it to have vSAN in it now. It's still an Excel spreadsheet. It's a hill I will die on, that Excel is the greatest database on the planet. And it's just accessible. It really is. People can use it. People understand Excel. They can filter in it, all that stuff. And so people have talked about databases and all that. Those are newfangled things. But we've added some scripts to automate the remediation, and mostly to provide an example of auditing and remediation. And that's actually what they're intended for, let people see how to do this. There's a lot of people that are really wary of automating. They think to themselves, the old adage of to err is human, but to really screw up, you need a computer. Well, they think about this. How do we do it safely? And so auditing is not that bad, but remediation can be tricky. How do you remediate something that might require your entire cluster to restart, that sort of thing? And so, just trying to teach people how to do all of that. But overall, just removing friction, thinking about how humans do this stuff, making it simple and easy to use, and yeah, so people can get on with their lives.